how complicated can a PCB holder even get? So to start off, I've had this little PCB holder from AliExpress for quite a while. It's quite small, it does its job, but I've always found it lacking a lot of features. So I thought I'd go ahead and redesign my own. So this right here is what I've come up with. First of all, it is much larger than this one. This AliExpress one is quite small, which is fine for a lot of circuit boards, but if you're ordering boards from PCBWay or JLC PCB, the maximum size you can get for $5 is 100 by 100 millimeters. So I've gotten one of these boards here. This is exactly 100 by 100 millimeters, and it cannot fit in this board. It's just slightly too big. With this one, however, this fits just fine, and it's got plenty of space. And it tightens in the exact same manner as this one. Now the jaws on this are 130 millimeters, and this is the biggest PCB that I have, and this fits in here with no problems. You see, I've tightened this down, and I can lift this up. So another problem I've had with this thing is that any boards with pins can't really fit on here. It's pretty much flat here, and the boards can't have any pins below them. So this is a problem for a board like this. This is an STM32 nuclear board. It's a development board of some sort. I've used it before, not so much anymore, but I'll use it as a demonstration piece. So no matter how you try to put this in here, it just doesn't fit. And it doesn't fit like this. However you try to put it, it doesn't work almost at all. With this holder, however, there's a huge slot right here, and it can fit this board perfectly well. So I've just put it in the holder right here, and you can see it fits perfectly. I don't know if you'll be able to see the pins, they're just right here. They're inside the gap, and it stays in here really well. This is ready for soldering, desoldering, hot air gun, whatever you want. Now the next most important thing about this is that these jaws can really easily be swapped. So right here, I have a 3D printed version just made out of PLA. I wouldn't suggest you do anything to do with hot air on these. Soldering irons, I wouldn't recommend getting close to them, especially if it's PLA. But if this was made out of the same material as this, so this right here is high temperature nylon, so that can take a lot more heat than this right here. And you can customize these however you'd like. You can adapt these to custom circuit boards if you're doing large scale production, or maybe even just large batches of boards. You can customize these to fit whatever board you'd like. These are installed with just M3 hex socket bolts. So one thing that I've transferred from these boards are these small cutouts right here. So they've made their way into here. I'm not sure if you'll be able to see it. So they're just right there. And they're used to hold up square boards. So boards often come in squares. I usually try to manufacture them in squares if possible, especially if I'm doing panels like this. And these can sit perfectly in here. And because these angle at 90 degrees and then themselves are at 45 degrees, they can fit any square board you'd like. And these slots are actually 1.6 millimeters below this top surface. So if your board is 1.6 millimeters, which is a really common size, then you can actually use stencils right on top of this board. I'd recommend you use smaller stencils on smaller boards, but I've found that decently sized ones also work pretty much fine. This slot right here was originally designed for a little piece of solder sponge, but I've been using this to store little components or just resistors, small chips, just in case I don't lose them. With a CNC version, it is a little bit hard to get at the components that are inside of here, but with the FDM version, I've filleted the corners on the inside. So you'll probably be able to reach in with your hands and just take it out like that. So with circular boards like this, or just circuit boards of unusual shapes, it's quite hard to keep them in place because the contact surface area is really small. If you try to push a soldering iron into here, it often flips or it just gets pushed around. So right here, I've designed a small little channel, and you can use both of these, and the circuit board is held in place like that. So pretty much, no matter what circuit board you use in there, you're always getting 4 solid points of contact. And if you push anywhere on the board, it doesn't go anywhere. Try pushing it around, and it stays in place completely fine. So here's another demonstration of another circuit board, and this stays in here perfectly fine as well. Ideally, with a circuit board like this, you would want to use this flat edge, and ideally these two opposite flat edges, but I'm using this as a demonstration piece. You also have square cutouts here and here, and also these kind of jagged cutouts here and here. I don't think they really have a purpose. I've designed them in because I didn't have anything else to put here, and I'm sure someone will find a use for them somewhere. So the design I've been showcasing here is actually made of aluminium. It's anodized red, and it's got a really good finish. These sliders down here, also CNC'd, and the black parts have all been made of SLS. These parts have actually all been given to me for free from a company called Justway. They manufacture all sorts. This video is actually sponsored by them. They, I think, have really good quality stuff. You can see machine markings, but that's because I didn't specify that I didn't want those. You can really easily tell them that you don't want machine markings, and for a really small markup, they'll go and post-process this and remove all of them. So I intended this to be a PCB holder that you could use in the reflow oven. So as you can tell by oven, the whole thing gets heated up, and it gets to 200 to 300 degrees. I personally wouldn't put this in a reflow oven, just because the glass transition temperature of these parts are actually all fairly low. You might get away with using low temperature solder, but I wouldn't really recommend it. I also have TPU feet. These will also definitely get melted. If you're making one of these, make sure not to include TPU feet, or if you do include these feet, just don't put this in the oven. Also, a really important thing, make sure your glue and your grease can actually withstand the temperature. The glue I've used to hold down these bearings and these rods is actually heat-sink glue. It's really strong and it can also withstand really high temperature. The bearings here as well, also rated for about 300 to 400 degrees. If you'd like to make this project, it is available on Printables for free. There's a CNC version and an FDM version. There's also a step file if you'd like to go and edit this, if you'd like to modify it. And I'd like to thank Justway for sponsoring the video again. Now, before you go off and order this, make sure these holes are the exact dimension in the step file. These are supposed to be 12.2mm, but they got manufactured to 12mm. Now, this is not a problem from Justway, of course, this is an issue for me. I should have stated that these have to be 12.2 or 12.1mm. With 12mm, these bearings don't fit, and I actually had to Dremel away a little bit of a material so I can push these in. The list of parts, bill of materials is also on Printables, and if you'd like, Justway can also tap these holes for you. I actually tap these myself, but it's really easy and fairly cheap to get them to do it for you. Now, that's going to be it for this project. Do like and subscribe to the channel. As you can see, I've just started the channel, really quite new. Every like, every subscriber really helps out. So, thanks for watching, and I guess I'll see you next time.